Okay. As most of you know, I'm Ian Young, G7III, as Barry just said. The RSGB, yet again, didn't manage to spell my name right, but that's not changed in years. So yeah, today I'm going to talk about weather stations and uplinking to the ISS. To be honest, this presentation could have been called Ian's Lash Up, it could be called Ultra Portable Operating, and any number of other topics, but I decided to keep it simple. It's divided into three areas. The first one, I will be talking purely about the weather stations, but that will hopefully only be a minor part of the talk. The bigger part will be discussing how we get those APRS packets up to the space station, and then the third part will discuss future evolvements that I have planned and one or two future ideas that turned up on Thursday evening, so I haven't had a chance to really let them distill. So it's much more going to be notes on what I've done so far and what I'm planning to do, rather than any very polished talk. So with that said, let's get started. Just a quick agenda, and I've already covered this, but a couple of extra things that I didn't mention. Well, one thing I didn't mention was the LoRa to Wi-Fi gateway, which I will discuss, but is really only at the design stage at this point. And by the way, just for the record, so what about the weather stations I've got? I've actually got two here, and you're more than welcome to come take a round. Powered by a Raspberry Pi or an Arduino Nano ESP32. Essentially, all they do is read various sensors, and I'll go through some of them in a minute, format and generate the APRS packets, and the weather station itself. The initial design was to send it via the internet, via Wi-Fi. So that was the initial design. Now, the first one, which is affectionately known as weather station number 1, is a Raspberry Pi with a very nice sensor board on it. It's powered by a solar panel, and this solar power manager, as WaveShare call it. Basically, it's three 18650s, each of 3,000 milliamp hours. The charger has a socket to connect the solar panel, so it can charge the batteries. It also has a socket for shore power and to feed the Pi and the sensor board. Now, this sensor board is very nice. It has about 7 or 8 different sensors on it, from pressure, temperature, humidity, UV, ambient light. I think it's got CO2. It's also got 3-axis gyros, which aren't of much use to us, but it is 37 quid. So you wouldn't really want to expose that to the elements. Yeah? Now, what to do instead? Well, I got to think about this, and essentially I can get the same sensors in individual sensor packages, such as these. Yeah? And again, there's temperature, humidity sensors there, there's pressure, there's a lightning detector as well, and a few other bits and pieces. Now, again, it uses the same solar power manager, but this one, which is affectionately known as weather station number 3. Weather station number 3 is powered by one of these things, an Arduino Nano ESP32. It does give me more life out of it than the Pi, because the Pi is very power hungry. Pi will last 2 to 3 days, depending on how much sun we've got and the time of year. The ESP32 will probably last an extra day or two, yeah? But it is currently unoptimized. So the Wi-Fi is always on, other stuff is always on, that I can turn off at a future date, yeah? Now, these still need protecting from the elements, yeah? So, anybody know what this is? Not quite. Anybody? Okay. It's a Stevenson enclosure. And so the idea is you put the sensors in the case, yeah, in the enclosure. There is a hole for the cable at the bottom. I will open it up in a minute. One of the fun games of trying to hold the microphone and play with the props. And you put those in there. That protects them from the wind and the rain, but still gives them access to things like the temperature and the pressure. This one will also have a wind sensor on it, plugged in there. That was soldered up by a friend of mine just this last week. And so that's weather station number 1 and weather station number 3. Those of you that have woken up from last night's dinner will note that weather station number 2 is missing. That is because weather station number 2 never got completed because weather station number 3 superseded it. They were being developed in parallel, and I moved all the stuff over. Yeah, so that's the two weather stations and how they work. Just a couple of pictures. This is number 1 in situ. Yeah, being tested. Yes, on top of my green bin, but it's convenient for me to pop outside the front door. Oddly enough, weather station number 3 is on the brown bin next door to it because it's also just outside the front door. You know. So, and then we've got the Stevenson case, or Stevenson enclosure, I should say. It has been tested with the GPS. These both have GPS receivers. The idea being I can take them anywhere, up a hill, Korea, yeah, places like that. And this is where the idea of sending it to the ISS came in. I don't know if anybody here has been to Korea, but it is one of the most isolated places, and you can only get there by train. They do have mobile coverage, supposedly. The word ropey would do it a big favour. They do have Wi-Fi, but only in the station house, not outside. So I thought, what else can I do? There's going to be no 2 metre stuff around there whatsoever. You're in the middle of the Highlands. So what can I do? Well, I took a look at the ISS passes for one of the holidays that I was planning, just before the issue with the ankle turned up, and checked the passes. And yes, we can see the ISS at times. So I thought, why not? You know. So, how do we uplink to the ISS? Well, uplinking to the ISS is no real different to any other iGate that you might run. Only difference being, one of the radio ports is on 145.825 rather than 144.8. Yeah? So, you know, it's, as I said earlier, it's not as hard as Barry was fearing. Yes, you do have Doppler effects and all the rest of it, but to be honest with you, I've uplinked just with a few watts, just any old ISS pass and just any old APRS packet in the past, so I know it can be done without, you know, huge antennas and so forth. The plan, because I want to be ultra portable, is to use a V dipole. Now, a V dipole is a horizontal V, and you aim it north or south, depending on which pass you're covering. All of this gear needs to fit in this, you know, and that's the largest rucksack you can get. It's an 80-litre rucksack, and to be honest, I couldn't carry 101 anyway. So, how do we build the eye gate? Well, and actually do the uplink. Well, I think most of you probably recognise these two. One's a Raspberry Pi 5 on top, and a Pi 2.0 on the bottom. Important to note that the initial iteration of this was very much designed to be shore-based, using shore-based power, just for convenience and ease of build and testing. However, as I say, you all probably recognise these two. Who here recognises the two radios on either side of the Pi? Yeah. Now these are, and I've got one here. I only brought one to cut down on weight. Yeah. Now, why use such an old radio? One, they're built bulletproof. And if you're going up into the Highlands, one slip and you're going to be falling over and damaging the more fragile radios. There is another reason. If you take the batteries out, which I have, they're long since died anyway, being NICADs, you can power it on and off via relay. That is harder to do with some of the more modern rigs with things like the TID radios, which I adore. I've got 4 of them. Because they're always powered when you've got the battery pack plugged in. Now, because I'm trying to go as low power as possible, I don't want the radios on unless they're actually transmitting. Yeah. The design, as you can see, uses USB sound cards. Yeah. In fact, this Pi is also controlled by a relay. The microprocessors fire it up when they want to transmit a packet. It then transmits the packet and shuts itself down again. Now, what are the considerations when transmitting a packet? Well, the initial design was, okay, I'll transmit one every 15 minutes just to get the design up and going. I have about 4 criteria. That is one of them. If it hasn't transmitted a packet in 15 minutes, it will send a packet, but not to the ISS. The only time it will send a packet to the ISS is if the ISS is above the horizon and it hasn't heard its own packet. Now, that needs a little bit of scripting, but I've got that script on some server somewhere from the past. The other time is if there is a lightning strike detected. Yeah, that's the 3 criteria. This helps save power, which increases the longevity, and it also stops me spamming the ISS. And so I think we've already been through this slide, why the IC02. And again, if anybody wants to see one in the flesh that hasn't done, there's one here. And so, one of the problems with going up to Korea is, yes, they have Wi-Fi, but I have tested it. It's not great outside of the station house. Literally, I walked out the door and had no Wi-Fi whatsoever. So, one of the ways to get over that is the LoRa to Wi-Fi gateway, which is only on paper at present. Just because I haven't time to actually build it, I do have the bits, but I haven't built it. And so what would happen there is the microcontroller would get a SPI-based LoRa board, and a second microcontroller that's already got Wi-Fi on board would also get a LoRa board. The weather station would transmit the APRS packet in text format across to the second microcontroller, which can then uplink it to APRS IS, or can pass it on to the ISS gate. So, yeah, okay, right. I'm going ahead a little bit there. So, now one of the things I'm looking at doing is merging at least two of these three. Yeah? There is no reason why I couldn't have the weather station and the radios under the control of one microprocessor. There is no reason why I couldn't extend the LoRa gateway to include the ISS gate as well. That's all, for the future. Yeah? So, any questions so far? Okay. Now, on Thursday night, when I was looking for some artwork to add to this, I came across this, which maybe it was the wine, but it got me thinking. We obviously can't do APRS over AX25 via QO100, that's verboten. However, what we can do is PSK. I found this by chance, so, and I say, it was only Thursday night, so I've looked at the blurb, and that's about it. Whether I believe it or not, I'm not sure, but it claims it's got 12 dBi. Now, 12 dBi gain, couple of watts, 2.4 gig. I think that could work, and it's lightweight enough that I can stuff it in my bag and not worry about the additional weight. That combined with a 60 centimeter dish would give me a QO100 station that I could potentially get up to Karur or Lundy Island or wherever else I fancy going in the middle of nowhere. So that is an idea that is germinating in my mind. So, and again, this is just a pictorial diagram of how that might work. It was only lashed up very late on Thursday night. As I say, that was one of those ideas that came just by luck. Yeah? And so, what else needs to be done here? Well, I've got to add the I2C voltage and current sensors for both solar and battery. As I said earlier, hopefully I can eliminate one of the nodes of the system. Because the idea is that it is portable. And by the way, just for reference, this is actually very slowly charging that right now. So it does work. So yeah, that's the quick version, of the plans and of what I've done so far. As I say, the next thing will be getting the sensors into this thing, and I'll just put the mic down for a minute, and I'll show you that. You basically do that. And then you have a nice area to put the sensors in. And yes, that is a piece of N-gauge railway I had lying about. It happens to be the exact width I needed, just to do some basic fit checks earlier this week. Yeah, and so yeah, that is planned for probably next weekend. Some people will be wondering why the ESP32, because it is extremely low power, and you can turn its peripherals off, including the Wi-Fi, and only bring them up as and when you need them. So it can sit there monitoring the sensors, and when it detects a condition where it wants to send a packet, it can fire up its Wi-Fi, it can flip the relays that are also going to be on the A2C bus, and then it can fire up the radios from there and send the packets on. So with that, I know that was short and sweet and quick, but does anyone have any questions or want to come and look at some of the gear?
Thank you. I think you said this was called a Stevenson enclosure.
Yeah.
And where would you purchase that from? Because I know everything else.
Right. That particular one I found at Paimori. No affiliation whatsoever. I was just looking for them, and I didn't want one of the big ones that the Met Office use. So I pumped in tiny Stevenson enclosure, and that one came back. About £13.50, I think. £13.50.
Any other questions?
Hi, Ian. This was really great, really thought-provoking. I was wondering if this concept could be expanded to other APRS spacecraft, or is that something you
We'll talk to other APRS spacecraft as well. All APRS-capable spacecraft respond to the two-call AR-ISS. So it will automatically do that. You don't have to do anything with it. I just picked the ISS because that's the reliable one, and I knew that I could see that from Korea. As I say, originally I was going to take this up in June, but then things happened, and suddenly, yes, that wasn't possible. So now it will an evolved version will be at EMF camp. So expect that, and then I've got another trip to Korea planned in August, so that'll be the real test for it and me, to be honest.
Thank you.
In that case, can I ask that we show our appreciation to Ian for putting his thoughts together and telling us?